This is Elaine McCormick Lab MO1 for constant velocity in motion. I rolled an orange at constant velocity under the assumption that Fnet equals 0, then created a model using my data to provide good predictions of the observed motion. You can see here in Tracker that I have uploaded my orange at constant velocity video. I chose the origin before the orange was at constant velocity and oriented the x-axis along the orange in the positive x direction. The center of the orange was marked for the average position throughout the video as the orange rolls at constant velocity. I used the calibration stick to set the leg scale for the video as 0.05 meters, which is the diameter of the orange. The time between frames was 1/30th of a second, and the total time is about half a second. You can see here as I play the video that the ball rolls at constant velocity throughout the whole time period. Using this data, I was able to create a model in VPython which shows an object at constant velocity. I used the mass of the orange, which was 0.074 kilograms, as well as the initial position found through Tracker, which is 0.045 meters, and put this in the initial position vector. Additionally, I found the velocity throughout the video, which is delta x over delta t, used for my data in Tracker, my total distance traveled over the time it took to be 0.847 meters per second, which was then put in the velocity vector within Tracker. I used a small time step for the model as compared to my half a second long video. When we run this, we see a ball at constant velocity motion in the positive x direction, which shows good predictions of what was observed in my orange rolling video. Then I compared the orange to the model in Excel using my data points. You can see that based from Newton's second law, when velocity is constant and the mass is not equal to 0, the Fnet is equal to 0, showing constant velocity as it travels from, this is t over distance, and it has a constant slope, which is constant velocity. Then we wonder, what if I chose a different place as my origin for this video? To do that, I will show if I chose a negative location and therefore had a negative velocity. When I run this, you can see that the ball will go in the opposite direction with an increasing negative distance, still at constant velocity, however it goes in the opposite direction. What does all this mean? When Fnet is equal to 0, as shown in Newton's second law, there's constant velocity. However, if I am to change the Fnet, and so I go into my Fnet vector and make it anything but 0, there will be a change in motion, and the velocity will no longer be constant. We see this when I run my model here. The ball does not travel at constant velocity, however, because there is a force acting in the y direction as shown in my vector. When the Fnet is equal to 0, we do not know exact pushes and pulls on the object. However, you do know that they are equal and opposite. That is what we can observe from this lab.